Imagine opening your favorite music app and seeing a playlist that fits your mood perfectly. Ever wondered how it happens? This magic is called machine learning. It's the technology that allows apps to learn from your past choices and predict what you might enjoy next. From predicting traffic patterns to suggesting the next video on YouTube, machine learning is everywhere. But how does this all work? Let's dive in and find out. Machine learning is a branch of artificial intelligence. It focuses on building systems that can learn from data and improve over time without being explicitly programmed. Instead of telling a computer exactly what to do, we give it data and it figures out patterns and insights on its own. Tasks like recognizing speech, identifying images, and making decisions can now be done by machines thanks to machine learning. With the explosion of data in the digital age, it's impossible for humans to analyze everything. It can process and analyze huge datasets quickly and accurately, uncovering patterns and trends that would be impossible to see with the naked eye. As we continue, we will explore the core concepts of machine learning. At the heart of machine learning are algorithms. An algorithm is a set of rules or instructions given to a computer to help it learn from data. Think of an algorithm as a recipe. Just as a recipe guides you in cooking a dish, an algorithm guides a computer in processing data and making predictions. Data is another crucial element. In machine learning, data is like the ingredients in a recipe. Data processing involves cleaning and organizing data before feeding it into the algorithm. Proper data processing ensures that the algorithm can learn effectively. Once data is processed, it is divided into training and testing sets. This process helps in refining the model to make it more accurate over time. Data quality is paramount in machine learning. The phrase garbage in, garbage out perfectly describes this concept. If the data fed into a machine learning model is poor, the predictions will also be poor. High-quality data, on the other hand, leads to more reliable and accurate outcomes. The data should be relevant to the problem you are trying to solve. Inaccurate data can skew the results and make the model unreliable. Consistency is another important factor. Ensuring that the data is clean and well-organized can significantly improve the performance of a machine learning model. More data generally leads to better predictions because the model has more information to learn from. A diverse dataset helps the model generalize better to new unseen data, making it more robust and reliable. Types of machine learning and overview. Machine learning can be broadly classified into three types: supervised learning, unsupervised learning, and reinforcement learning. Each type has its own unique characteristics and is suited for different kinds of tasks. Supervised learning involves training a model on a labeled dataset. Unsupervised learning deals with unlabeled data, finding hidden patterns or intrinsic structures. Reinforcement learning is inspired by behavioral psychology, where the model learns by interacting with its environment and receiving rewards or penalties. This type is particularly useful for tasks that involve decision-making under uncertainty. In the following sections, we will delve deeper into each of these types to understand how they work and where they are used. Supervised learning. Learning with labeled data. Supervised learning is like teaching a child with a set of flashcards. You show the child a picture of an apple and tell them it's an apple. Similarly, in supervised learning, a model is trained on labeled data. The labeled data consists of input-output pairs. The model learns to map the input images to the correct labels by finding patterns in the data. Supervised learning is used in various applications like spam detection, image recognition, and medical diagnosis. For instance, spam detection systems are trained on a data set of emails labeled as spam or not spam. Unsupervised learning discovering patterns without labels. Unsupervised learning is like finding order in chaos. Unlike supervised learning, it doesn't rely on labeled data. Instead, it tries to uncover hidden patterns in the data. One common technique in unsupervised learning is clustering. Clustering involves grouping data points that are similar to each other. For example, imagine you have a data set of customer purchases. Unsupervised learning can help you identify different types of customers based on their buying patterns. Another technique is dimensionality reduction, making the data easier to visualize and analyze. Unsupervised learning is especially useful in fields like market research, bioinformatics, and anomaly detection. Reinforcement learning, learning through trial and error. Reinforcement learning is like training a pet. You reward it when it does something good and discipline it when it does something wrong. In machine learning, reinforcement learning uses a similar approach. An agent interacts with its environment and takes actions based on the current state. Each action leads to a new state and a reward or penalty. The agent's goal is to learn a policy that maximizes the cumulative reward over time. One famous example of reinforcement learning is AlphaGo, a program developed by DeepMind to play the board game Go. Reinforcement learning is also used in robotics, where robots learn to perform tasks by trial and error. The potential of reinforcement learning is immense, especially in areas that require adaptive and autonomous decision-making. Practical applications, recommendation systems. One of the most popular applications of machine learning is recommendation systems. These systems suggest products, movies, music, and other content based on user preferences. Recommendation systems use algorithms to analyze user behavior and predict what they might like. There are two main types of recommendation systems: collaborative filtering and content-based filtering. Collaborative filtering relies on the behavior of similar users. Content-based filtering focuses on the characteristics of items. These systems have become an essential tool for businesses to engage and retain customers. Practical applications, self-driving cars. Self-driving cars are a marvel of modern technology. They use machine learning to navigate roads, avoid obstacles, and make driving decisions. Self-driving cars rely on a combination of sensors, cameras, and machine learning algorithms. The sensors collect data about the car's surroundings, such as the position of other vehicles, pedestrians, and road signs. The cameras capture images and videos, which are processed by the algorithms to identify objects and interpret the driving environment. Machine learning models are trained on vast amounts of driving data. They learn to recognize traffic patterns, obey traffic rules, and make split-second decisions. Companies like Tesla and Waymo conduct millions of miles of test drives to ensure safety and reliability. Self-driving cars have the potential to revolutionize transportation. Practical applications. Fraud detection in banks. Fraud detection is a critical application of machine learning in the banking sector. Banks process millions of transactions daily, and identifying fraudulent activities manually is nearly impossible. Machine learning helps in detecting suspicious patterns and preventing fraud. Fraud detection systems use machine learning algorithms to analyze transaction data. They look for anomalies or unusual patterns that may indicate fraud. The algorithms are trained on historical data, including known cases of fraud, to improve their accuracy. By analyzing large volumes of data in real time, these systems can detect and respond to potential fraud quickly. Machine learning also helps in reducing false positives. Fraud detection systems are essential for protecting customers and maintaining trust in the banking system. Unlocking the secrets of machine learning. Machine learning is transforming the way we interact with technology. From personalized recommendations to self-driving cars and fraud detection, its applications are vast and varied. Understanding the mechanics of machine learning helps us appreciate its potential and the impact it has on our lives. The journey of machine learning is ongoing, and there is much more to explore. If this beginner's guide has piqued your interest, there's a whole world of machine learning waiting to be discovered. Dive deeper into topics like deep learning, neural networks, and natural language processing. Consider taking online courses or reading books on machine learning. Engaging with the machine learning community through forums, blogs, and conferences can also provide valuable insights and support. Don't forget to like, comment, and follow for more insights and updates. Embark on your machine learning journey today and unlock the secrets of this fascinating technology.